So in the spirit of being scientists, we're doing a couple of experiments here. One of the experiments is that it's not just the Chris Digdigian show.
Finally.
This was at Chris's request. He's been doing this gig since 2008, soloing it. Another experiment is this thing, where we're technologists, right? We use technology to move information around and to collaborate, and we can it was stunning watching the slides for this come together. We used a collaborative slide editing software, and I got to watch something as smart as these 5 people all working simultaneously on a document. And it wasn't any one personality, and the ideas fed off of each other. It was amazing. And so this is another thing in that spirit. If you want to play, it is a little software service where you log in, you don't have to use your real name, and you can propose questions. And even if you don't want to propose a question, you can vote on questions. And when things hit a laggy spot, I'll just go to the top of the list, and assuming it's not too profane, I'll read it, and the group will respond to it. Another experiment we have are these microphones. And let me demonstrate how these get used. Angel, if we could.
Yes.
Totally harmless. And also I've seen these in use where people will want to play, and it will draw people into the conversation, where you throw somebody the microphone, and they'll want to play enough that they're willing to speak up. Who knows?
There's a rule. If you don't ask questions, you're getting it thrown at you.
Oh, yeah, that's another thing. If the room goes really dead, I'm just going to start throwing it at you. And like I say, all of these are experiments. We do experiments not because we're certain they're going to work, but because it is an interesting thing to do and we intend to learn things. But backing all the way up, we have 5 members of BioTeam here today. We're going to go, give or take, 12-minute presentation, 10-minute talk for each of 5 people. We're going to flex on the schedule. It'll be fine, right? We have actually less than 1 slide per minute, so we've fallen off that whole thing. But it still feels like a really great, large amount of material we've got. I won't bother reading it to you. I'm excited about the fact that we have sobriety, discipline, sobriety right at the end of the conference. And at the end, I'm going to ask the panel to put out 1 or 2 sentences which are the summation and what people should walk away from this conference with this year, which I think is potentially what we kind of want. What are we going to go home and tell our bosses that we learned at the conference? What is the tweet? And I expect you to disagree. So this is a picture from, I believe, 2002. On the right, you can see Mr. Digdigian. And from right to left, there's Dag and Stan and Bill, who is down here in the front row, and Michael Athanas. These are the 4 founders of BioTeam. And this particular company has been associated with this conference for its entire duration. And I dug back. I think Dag started doing the Trends from the Trenches in 2008. Right? It was referred to as the unofficial keynote until they made him the keynote. I dug through this and found this thing where, as of 2008, all of us had deployed something on EC2, which we now know as the cloud. So we're actually in the 2nd decade of cloud technologies. That's pretty cool. But there are these new people, and I thought I would just to play a little game with the personalities. It turns out it's not strictly 1-to-1. But the weirder thing for me. And if your mind runs to numbers, then you start looking at the composition of the letters in these names, and there's other patterns in there. I don't want to go into them. But there's a lot of A's and doubled A's and skipped A's and stuff, and I'm sure some sequencing person could make a bit of an analysis of this, and that would be great. I do kind of want to avoid this. The short speeches disguised as questions. Really seriously, I want to keep this very interactive and moving rather than be too grandstandy. And with that, I am going to sit down and stop grandstanding. And we're going to bounce directly to, once again, it's pronounced Slido, to Aaron, who's going to kick it off with some distinction between hype and reality.
Knock him dead, Aaron.
Thanks, everybody. Yeah, I get the distinction to go first, and I'll try to set the bar low for my colleagues. I think I can do a good job at that. So yeah, let me see. Well, I can advance this slide. That's a good start. So really what this talk is about is just some thoughts on, hype technologies, some thoughts about, technological realities in this day and age, and then just kind of other random thoughts in between. We were just talking a minute ago. I made sure to make a lot of content in here questionable for you all, so you can ask some questions. So I just wanted to, kind of set the stage here saying that, we're currently so oversaturated with communication distractions and context switching that we overshare, we don't have time to fact check, and these things really amplify hype. So really the main takeaway, you can turn your brain off if you need to do that from here on for me, is just focused execution is the ultimate dose of reality and hype antidote. And I think it's especially important for all of us to realize we probably have a lot of leadership in here in terms of technologists and things like that. And it's just very important. Sometimes we can get so abstract and so hype-ridden that we can lose focus. So first thing is to say, don't have a technology-first strategy. It's my belief that we can't experiment with and evaluate every new technology. I kind of know this because it's BioTeam's job to try, right? That's my job, and I'm not very good at it, but I try. And so, really understand the scientific use case first. We've probably underscored this in a lot of our own talks, and you've heard that a lot while you're here. Focus on your pain. Really, even for next year coming to this conference, bring your pain. Don't come to just check out new technologies. Bring your pain and spend some time to really quantify that pain. We're talking about what efficiency gains you need. What are you looking for in terms of capacity changes? What are you looking in terms of agility changes to your infrastructure and technology and how you apply them to scientific research? So then you got to, basically map that to a technological delta to provide the relief, right? And choose your medicine. And then lastly, counterintuitively, this actually allows you to be more innovative and creative. A quick example is as virtualization was coming on the scene like a la 2005 or 6, if you just blindly applied that abstraction model, you go, okay, well, this is a good technology, let's apply it, and you kind of would have moved your legacy infrastructure into that. But where I was at the time, I was fortunate enough that we were going, well, what is our pain, and then what does virtualization enable us to do? So then a full decade ago, we were essentially building a microservice-oriented architecture that really led to a lot of big wins. So you can often kind of leap a bit forward if you start with the pain and map the technology to it. So I thought I would have to lift everyone up. I don't know how motivated everyone is right now, but TechCrunch meme. A lot of bio-IT trends talks we talk about, it's a really risky time to be doing bio-IT. So I feel really tethered to this thing. So it's an insanely awesome time. I could use that, could I? Couldn't I? So it's an insane and insanely awesome time to be doing bio-IT because there is just so much transformation happening in IT and technology in general. One could say, well, that's always true. I just feel it's especially poignant right now, even just given my career and experience. And I'll get into a few reasons why, and the ones I missed, these guys will cover. So quick note about cloud. Pay attention to Dag's thoughts on cloud sobriety and also, cloud wins and pluses. One thing to note for those who don't know me, I'm actually a lot contrarian with a lot of technologies, and I don't really like cloud, but these are realities. It's still true that it's not a cost play, it's a capability play. That's why most have adopted the cloud and been successful, because in reality, most of us just don't have the engineering to produce the APIs and stabilize adopting new technologies in a way on-prem that we can in the cloud. So this is true for pretty much everything except infrastructure as a service. So that's why that regular expression is there. There's no drop-in replacement today, again, except maybe for IaaS. We've tried. I think we're going to move on to other things, and maybe we'll get it right on-prem later. We will go to the fog and then finally get back to on-prem with the goodness that is in the cloud today. So there's a lot of hype around multi-cloud and multi-org. In 2017, we're really seeing a lot of that. It's a good thing. We all need to get there. It's more hyped than canned reality right now. Same for, since I've been at BioTeam, the whole idea of hybrid cloud with a really strong consistency model. Again, that's a great thing, but it doesn't really exist quite yet. So another topic I really like is converged infrastructure. So basically, our view of converged infrastructure is a little different than than others in that we really think about it all the way from the laboratory to knowledge and everything in between. And so why is this an important concept, given how buzzworthy it's become? Because really unifying, integrating, and simplifying what we do allows us to make room for what's next. Things are getting more complicated, not easier, right? We all feel that and see that. And so you really need to abstract and distill in order to even have a chance to step forward into what's next. And converged infrastructure lets us do that. And it's also going to allow us, to take more of the hardware practices we've come to put in place and allow them to become software, which allows them to be more malleable. So things like network function virtualization and other things. Let your mind wander there or talk to me after. I don't have much time. So hype, everyone has a converged offering, just like everyone had a cloud offering. A lot of these are actually business partnerships masquerading as converged solutions. That's what that acronym is. And one thing to really be careful about, because in some ways the enterprise is ahead of us here, taking legacy things and putting them together until you kind of wind up with a converged solution, especially if those were closed or commercial offerings, you can very easily sprinkle licensing to such a point that the in-app purchases are going to make converged offerings, once you get up to the platform and service level, incredibly expensive. So just watch for that as far as the converged offerings coming from the enterprise side. And really, the two needs we need around converged infrastructure that we really lack is specific solutions from a hardware and software perspective that fit scientific and research use cases. We just weren't the driver here. And also, we should design these solutions to be driven by scientists and not operations staff. That would be transformative. A word on big data. That's a big data in a dunk tank. So I guess I'll put a period after that. So really, to me, big data has never been a thing. We're transitioning from the information age to the analytics age. This has been in play for a while now. And so one of the things we've learned through, grabbing onto this hype was that, it was really just a transition to a new epoch. What's good for, an insert, hyperscale company there is not necessarily going to solve our pain points. And so a lot of folks, though, kind of bought into the hype and felt they were missing out, and sadly, rushed to implement blindly, not considering the use case or application carefully enough, a la my second slide. And so that just led to a lot of waste and churn. And so, but the reality is we do need new methods in the analytics age, and a lot of those that came about during the big data buzz will and are being used. And really those that do adapt and use those will win, and I do think it is dire enough that those who don't, really risk extinction in a general sense. So another word on the newest buzzworthy trend, right, in 2016 and 17, artificial intelligence. So just like, all buzzworthy things, it's not really new. But I think as a society, we've seen some limited and correct applications of AI. And those really generated a lot of hype because it was exciting. They were palpable for us. I know I love having the right people suggested to join my meeting on my mobile phone. Thank you, deep learning. Those things are cool. And then that kind of overcame the confirmation bias we've all had around AI. And so so then once the genie's out of the bottle, right, everyone is buying into the hype, or fearing the hype that AI is going to solve everything and steal our jobs. The reality is automation's been stealing jobs forever. You can see my example. The reality instead is that AI is going to help us focus better. It's going to help us distill information better because we've quickly reached a point where we absolutely cannot use even crowdsourcing to distill all the information we have and make it intelligible, infer meaning from it, and derive value. We really need to leverage AI to help us filter these things and be careful of neural network bias along the way. So words on compute and storage hardware. This is kind of just a smattering of things that are in my head. I'm kind of conservative about hard disks. I mean, people have announced that SSDs were taking over forever. Companies have been, their R&D is largely focused on SSD and now 3D XPoint the last 2 to 5 years. What we're finally seeing is actual fire and not just smoke in terms of manufacturing facilities shutting down and the economic curves looking like they're converging nearer term. So this is a here and not yet kind of situation, but definitely do prepare for primary media to shift away from hard disks in the next couple of years. It's really I don't have enough time. So watch AMD in 2017. Look at things, not only their CPUs and PCI Express lane considerations, see later in the slide. Also, check out ROCm. It's a really interesting idea for shared virtual memory between main memory and GPU memory. So hype, this is one thing that kind of breaks the premise of the talk. We're still kind of beholden to folks, providing things for us in hardware, and when we have FPGAs, we're going to find problems to fit that solution. So in 2016 onwards, we're playing a PCI Express lane game, and this is largely a function of all of a sudden having a lot of faster storage, and NVMe over Fabric is very much a real thing. That's going to be coming more and more in the next couple of years. I think I'll just skip down to saying there's not a lot of time to distill this slide right here, but what the takeaway is that PCI Express switching and low latency Ethernet and IB on the LAN do have the latency to correctly present not only solid state NAND, but NVRAM like 3DX point properly over the network. So this is why we're going to migrate from compute clusters to also having really data clusters and huge points of presence on the network fabric, and we can do that. Although trying to globally share main memory, which would be a lot greater, we're still not quite there yet. We have to do latency hiding tricks, and it's not perfect. So software. You know what? I think a lot of people are going to cover this. Adam Kraut's going to cover a lot of this. Pay attention to the Lambda function and serverless stuff that he presents, and then maybe refer back to these slides later. As far as workforce transformation, Asya will have a lot of good words on this. I'm going to kind of drive home. I'm going to maybe take a couple more seconds, but I just ran out of time. Asya is going to talk about this, but I'm going to drive home what Chris said, that really with DevOps, you just can't even, unless you're practicing that, you can't even get invited to the party for where we've evolved to, and that really it's very hard to find people that have the right mix of web scale and research skills, and especially high performance computing. And I'll just end with saying we're doing a really bad job at shaping user experience. And presenting things that are usable for scientists and non-technologists, and that would allow more people to be in the party. And we shouldn't just be creating things for each other to consume and make life easier. So as far as what this all means, I'm going to skip past my idea and just say focus and pay attention to the rest of these talks. Thank you, everybody.
So
We have time for questions.
we have time for questions. I actually I'm not actually texting here. I'm looking to see the questions that were asked. Who's the person who asked if I could reach the back of the auditorium?
Challenge accepted.
I'm gonna need an assist.
Keep going.
Let's get it to the back.
This is-
All right. Yeah.
This is workflow automation and process.
All right.
And if it comes to hand, you may ask a question.
I guess the answer is yes.
Other questions?
You're
Nice.
You will have it thrown at you. There's one in the back.
Oh,
I don't know if I can throw that far. There we go.
Thank you. No worries. Hey there. So,
Hello.
in terms of the evolution of cloud demand, it seems like we went from cloud to, well, now that doesn't seem to work for everybody's workflow. What are you seeing specifically? What's your perspective on that?
So the question was cloud and
Well, I don't want to
workflows
turn it into a speech like the New Yorker cartoon.
not working for every use case. Go ahead.
I mean, it seems like over the past 5 years, it was we want to go to cloud, but we can't because of privacy, because of regulation. Then there were better technology solutions to better facilitate that. And now some of the market seems to be responding with, well, wait a minute, why am I waiting 6 days or 6 weeks for this workflow when I can just do it more cost effectively on-prem? And more to the point, when you run out of money, you need to get another grant or you need to be on-prem. So what are you seeing in terms of that, and what do you think the future holds in store for cloud working together with scientists, with bioinformaticians?
Oh, good question. So, I mean, I think that point that was made in the slide saying cloud is a capability play and not a cost play is still true, and that I agree with you in that sense that things can often be done more efficiently with your own infrastructure, especially if you have sustained workloads that are measurable. Again, people went to the cloud because it has API everything, because tons of engineers have proved things out that even if you have the hardware on-prem, you just can't fit the software to it to do it. And so I think what will happen over time is people will kind of put two and two together, and I think they are. Pay attention to Chris Dagg with Cloud Sobriety, that basically workflows will start to be done on-prem with the same level of software engineering and that we have in the public cloud now. And it's just going to be a matter of time, and I don't know that the public cloud providers will be the ones whose software stacks are used in that sense. Anyone else who has any comments here, please jump in.
I would add in that I think you hit it on your first couple of slides, where the, and I completely agree with this, that cloud as a pure technology play does not actually address any particular business need or any particular scientific need. You know, if you focus instead on the actual business or scientific pain point, we're starting to see some really remarkable transformations where whole categories of former, whole former categories of work simply move to different organizations. And you're starting to see different workflows enabled because of cloud. But yeah, the just like legacy lift to a hosted environment has not been as successful as it could be.
Amen.
So we have another one from online, which is thoughts on serverless architectures. And they use the acronym FAAS, so something as a service. What's F? Functions? Okay.
Yeah, thank you, Kraut. So yeah, pay attention to Adam Kraut. He knows this stuff, see? Serverless is absolutely where things are going to go. I didn't get to talk about it much, but, we have to simplify, and not just like converged infrastructure. We really need to start thinking about a multi-cloud internet scale orchestration framework governing how we do our workflows and workloads. And to do that, we really have been continually shedding legacy cruft, and even a multi-user multitasking operating system is on the chopping block. So I think the success of things like AWS, their Lambda service and other things are starting to really prove that point. I think we're only going to see more of that. But please, anyone else jump in.
Yeah, I would just say I think serverless is kind of just a byproduct of hyper-converged infrastructure, right? So it's just a new capability when you kind of put all this infrastructure together that you can now run code, directly on the same platform as the storage. I think it's also interesting to look at some of the storage vendors and how they're enabling things like Lambda in their storage appliances. That's going to get really interesting too. So it's not just going to be Lambda in the cloud. It's going to be doing Lambda-like things on-prem and maybe events flowing between both systems. So I think I definitely think it's here to stay, and it's just a byproduct of how we've been developing infrastructure.
In storage processing.
Yep.
All right, so that was one person. I'm going to ask that we move on to the next one, Asya. And similarly, let's just continue the conversation here. I'm excited about the fact that the back of the auditorium is participating.
Hi. So my talk is titled Data Transfer and How to Deal with Millennials. I'll explain. Data transfer because I'm bored with data management. And how to deal with millennials is basically to get you in the room. And I think it worked. Do I advance slides here on the laptop?
Just arrow down.
Okay. So I like this to be an exchange of information, not just us talking at you. I'm going to ask you a question, and if you feel like participating, just raise your hand. Who here has big data or something like it, or somebody who thinks that they have big data? Okay, about a third of the audience. How big is it? Raise your hand if you think it's big. A lot less, okay. Is it all in the same place or 1 to 5 places? Okay. Is it 1 to 50 places? Is it more than 50 places? Okay, so middle. Do you know what it is and how old it is and who owns it? Raise your hand if you do. Not bad. Is it secure, and do you worry about losing it? Is it secure? Do you worry about losing it? Okay. Do you need to share it? Everybody. Is it 1 to 5 people / departments? More than that? Do you rotate or retire your data? Not a lot. And do you know how much of it moves, is duplicated, and how often? Do you have any insight into that? Just you know? Okay.
One poor soul.
Okay. So I'm tired of the word big data, so I'm making it look like a swear word. / programming, so that's a little bit more interesting than just big data. So that's one of the topic. Explaining what it means to different people, because it doesn't mean the same thing to everyone. The next topic is it's no longer hype, and it's no longer getting your feet wet. It's kind of like cloud 5-7 years ago. It is now in production in a lot of places. And it's no longer just static data management. With microservices, it's a lot of interaction between data without human involvement. And then the fun slide about history, I think you're going to like it, and the current landscape, and the more buzzwords like data lakes. I like them to call them ripples on the lake. And what happens in the future, or at least what I think what happens. Definitions. So we like to start with numbers. Every time we work with a client, we ask them a lot of boring questions. Like, what does it mean, data, for you? Is it a typical NGS data set when it comes off the sequencer? Is it in the range of 100 to 500 gigabytes? How frequently do you run your sequencer? Is it 24/7? Is it only 5 days a week? Is it run only once a week? How many sequencers do you have? Do you consider this high throughput? Do you have one of those fancy X10s? That all matters. Do you have any microscopes? Do you have any newest and greatest cryo, which can be 24, 25 terabytes per run or per day? Do you have any partner data sets? Is it a one-time transfer where you just partnered with someone or acquired someone, and is it like 10 terabytes or about? Is it in the cloud? Are you streaming data from instruments or from any other technology? Do you do snapshots? How often do you do that? Do you need remote visualization? How far are the people that need access to the data? And access by people and by software are two very different things. People don't typically need access to a lot of data. Software might, and in parallel. So the discussions that we've been seeing are, your instruments are in the lab. You really need to save that data as soon as it's generated. It's typically on local disk. It shouldn't stay on local disk because it'll fill up, and then your instrument will stop producing data. It'll crash. It'll cost you $5,000 per run. That's not good. It needs to go somewhere. Do you have enough space for it to go somewhere? The instrument is probably 1 gig. You need to have adequate storage. If you have a dozen sequencers and they're all running at the same time, you need to make sure that storage is capable of receiving that data. So you need to make sure there's adequate network connections and at both ends. Then you probably will not have central storage there. You'll probably have some sort of enterprise solution, which means your local instrument cache needs to transfer then data to some central location. So the rate at which the data is transferred is different between the instrument and that temporary location and then your centralized storage. It's probably going to be faster between that cache and centralized storage, 10 gig, 40 gig maybe. You really need to track the data as soon as it's generated. And typically with NGS runs, you already have some metadata in the text files. It really needs to be parsed right away and tracked throughout its lifetime, at least the project, if you are not doing anything else. Because everybody talks about chargeback, and that's really where you need to start tracking the data. And by now, no one does this manually. I mean, yes, people still write Python scripts occasionally, but it's just too much work. It really should be automated and triggered by events and not by people. And I swear I did not see your slides before I wrote this. So we're just basically all think the same. So what does it mean that it's not static data management? I'm a system administrator, so I've administered NetApps before. NetApp for research is just not a good thing. So POSIX file system with locking in a single location with 2 10 gig connections is not going to work for multi-site collaboration. Hopefully that's obvious to everyone by now. Without adequately distributed and replicated storage, there will be network congestion and duplication of data that is hard to track down. You really need to know where your data generates and where it needs to move before you start designing your storage solution. When your data moves and changes all the time, it's important to keep checking for consistency because networks are not reliable. So every time your data moves from point A to point B, you need to run checksumming. It takes time. That means it ideally needs to be built into your storage solution, and likely some sort of accelerator will be used for that. Encryption, same thing. It's done more and more, and it also takes time on both ends. The automated workflows are generating more data faster than a human ever could. No one even thinks about that because everybody assumes that data is generated by humans. That is not the case anymore. There are more and more instruments. Prices are coming down. The workflows on the data, pre-processing, post-processing, are frequently now triggered by data simply landing in an S3 bucket. A lot of workflows in the cloud do that. No one logs in into an S3 bucket to do something with the data. It's an automatic workflow that does something to the data, then it moves somewhere else. And that model in the cloud is becoming more prevalent on-prem, or should be. So the fun slide. And again, I'm curious how many people here would remember this. Who wrote Perl scripts to traverse a POSIX file system to find out who owns the data and how old it is? Cool. Did you ever had to change ownership on all the files in a directory with more than 1 million files? Exciting, huh? Having to move 500 terabytes, pick arbitrary large number, and having to borrow equipment from the vendor to move to the new platform, right? Because no one thought about that. Moving data using Aspera, which is super efficient at moving data, and forgetting to set any sort of standards on your network and then bringing the whole enterprise network down. I did this. Enabling duplication on the volume and not realizing that it's 70% full, so it's not going to happen. Which is funny to me because you are trying to make some room and you cannot, right? And then finally getting a really fast network card and getting really excited, and then the data is not moving because you really need a lot of drives on the other end as well. Glad to see so many people had been through the same things. Okay, so Hadoop and Spark are no longer an experiment. A lot of companies are using it. Sometimes it's shadow IT, sometimes it's scientists just doing things on their own. And it's working for them, and the next thing you know, it's in production. They are both not a temporary thing. They are staying for a number of reasons, and they get their data from both structured and unstructured sources. And by structured, I mostly mean databases, but it could be something else. It happens frequently and potentially on a schedule, because sometimes when you have streaming data, it's coming in daily. And if you have any sort of hiccup in that schedule, then you're potentially delaying a deadline, and people are going to be really mad at you. Visualization is now capable of driving those automatic workflows. People regularly use tools like Tableau or Qlik or Spotfire to come up with an idea, and then, scientists, they get excited and they want to implement it right away, and it's a 500 terabyte data set and need to process it right away, so the data needs to move. And all of that needs to be versioned, snapshotted, and tracked because scientists don't trust anyone, and they want to know that it'll run exactly the same thing, or somebody else will be able to run exactly the same thing and reproduce the results. And a lot of data sets come from partners. People outsource sequencing. They store it in S3 buckets, and they want sometimes to bring it in-house or process it in the cloud or bring the data to the cloud. So it moves 3 ways. So what happens next? Vendors used to be reluctant to take on more than their core expertise. That is changing. I work with a number of vendors that used to shut me down a number of years ago. They would just simply say no, and now they're thinking about it. They're saying, well, bring me more clients that want it, and we'll think about it. Frequently, vendors have a lot of integrations when they don't have a staff in-house to get something done, so they're a lot more open to partnerships. And I guess that's the acronym that Aaron was using, whatever as a service license model, App Store. Authentication, authorization, federation are becoming a lot more important. It used to be hacked together, and now there is a lot more need for solutions. If a vendor doesn't have the greatest technology built in, or at least a roadmap for something like that, there's less trust. It used to be the other way around. A vendor would come to you and say, I have this thing, and you'd be like, no, we're enterprise, we don't do that, we'll wait 3 years. Now you really want to hear the buzzwords from the vendor to know that they are keeping up with the times. And nothing is ever simple anymore. It's not just NFS. It's at least 3 different types of storage. It's local and remote. It's multiple clouds. It's multiple vendors. It's actually kind of insane how many things you have to work on with daily, and it's not just research. A lot of it is in production. So what does it have to do with millennials? Yes, I know there were other generations before millennials, but in technology, I think for the first time I saw that term used as a thing to define people and the behavior in the workplace. And I'm sure you've seen blogs about it, but I've seen it, so I believe it. They are changing how things are, and they're pretty annoying when they're doing it, but there's just no escaping it. So you'll be in a meeting and they'll say something like, this is silly. And you're like, okay. How am I going to talk to this person? But that's what they do. And I actually like it because sometimes you'll spend a lot of time trying to convince somebody of something, and it's futile, and they'll just say it's silly and move on. They try new things fast. They're not scared of new things, and they're not overwhelmed by new things. And they hate documentation, but love version control. So they're the people that are and will be implementing all of this technology for the next 20 years. So I know this sounds obscure, but I think a lot of organizations will have to change their culture. They don't have a choice. And as much as we're preaching about it, they're going to be forced to do it, whether they like it or not.
That was awesome. We got a raft of questions asking for specific recommendations on like managing lab data at the edge, caching in toward a core or a commons, and standards to get back out to another edge and sandboxes. Are there specific things that you could recommend to ease that pain point?
There are no standards. There's sort of a short list of best practices. The one very important thing that people forget, instruments are usually Windows. So you're dealing with 1 gig and you're dealing with Windows. So the easiest thing to do is mount some sort of CIFS or a Samba share. That is super not performant and not reliable. So you definitely need tools, at least on the receiving end, to make sure that data did get there. Second, sometimes people install executables on the Windows system to make sure that the transfer happened somewhat faster in a parallelized manner. Illumina has tools for this. They allow you to install software to speed this up. There are no good tools currently that I know of that check things on the instrument side. So you definitely need to have something that manages this. We like iRods. It's not easy to implement, but it's kind of a unifying tool that does a lot of things, including data management and registering the events when they happen, and has the ability to trigger something that will kick off after the data is received. There are modules for checksumming. Configuration management like Ansible has things like that built in, makes it a lot easier. Hopefully this answers the question.
It does for me. Other questions in the audience? Who wants to play catch?
And/or we have an old-fashioned microphone. And I will be happy to bring it to you.
Got someone in the middle?
Deb's fired.
All right.
It's challenging to throw.
So with the millennial generation not having any reservations about putting their entire life online in any number of web-enabled media, what do you think of the prospects over the next few years of all of this privacy infrastructure that we're now having to enable because of, obviously legislation, but when this generation passes through and becomes the lawmakers and says, genomic data, who cares? We may as well make it public, or any other, except for maybe credit card and social security numbers. How much of this infrastructure that we spend millions to billions of dollars implementing do you think is just going to go away?
Anybody remembers PGP? Maybe it'll finally be built into everything.
I personally, and my colleagues will know this about me, I think privacy is a myth that we put a blanket over so that we can all feel secure and hope that we can do things. The truth is that no matter what you do, if someone wants your stuff, they're going to get it, right? And that's why I'm following this up with, security sobriety at the end, precisely for that reason, because there's different ways to do things, and such that your social security number and your credit card shouldn't matter, right? There should be additional security in place that doesn't let anyone else use it. We do have the ability to do that today, so that's my personal opinion.
I'll take a contrarian view on the millennial and privacy. I think if you see the way things are going, especially in the U.S., the first time a millennial gets denied health insurance because their genetic data exposed to pre-existing condition or expensive record, the first time they don't get a job offer because the employer buys a data set that suggests they might be expensive as an HR asset, I think the millennials will be pretty damn strong about their security once they realize the sort of adverse outcomes that could affect their health insurance, career, and job prospects.
I want to just second what Chris said, that I just think the privacy bubble hasn't popped for them. I really agree. And I don't have a LinkedIn or Twitter or anything else. So if you ever see anything with my name, it's fake.
And as an old millennial, I just want to say that none of that applies to me.
That seems like a lovely time to work in the blockchain question. Which, I mean, my opinion is that it's at the absolute peak of the hype curve, and we're about to enter the valley of disillusionment. But there's technology in there for, securely, publicly exchanging private information, in a sustainable way. Have you folks seen any meaningful application of blockchain technology that couldn't have been done just as easily without blockchain?
It wasn't a VC pitch?
No, not from my perspective. I haven't seen it.
Have you seen the
Aside
price
from
on
people
Bitcoin lately?
I think the attraction of blockchain and PGP is both decentralization. So decentralized security is going to have to be implemented in some way, shape, form, or fashion.
Yeah, there are some interesting startup companies for microservices and things that we're looking at that start to address this kind of global concept you were applying to blockchain. So we have to go there. Go ahead, Art.
Yeah, I think the most reasonable application so far is what Asi was just saying, is the decentralized security because of the Internet of Things, right? It's very unsecure, as everyone noted about 6 months ago. So I think that's where it can happen.
It's an area open for innovation, that's for sure. Everybody jump in.
We can throw microphones at you.
Actually, a kind of remarkable thing about this conference is that sometimes if you express a question or a concern or a pain point from this stage loudly and clearly enough, you show up next year and somebody sells it to you.
Yeah, yep. There will be a blockchain booth here next year.
All right. It's you.
It's actually harder to talk for 12 minutes than to, do 150 slides in 45 minutes. So I'm going to try to go relatively quickly and sanely here. I just want to thank all you guys for showing up, and also thank all the people sitting here at the table here. This event is an outcome of me being a whiny little baby about the Trends from the Trenches talk. Not only was I running out of interesting things to say, but I kept feeling that there were other people who had equal or more interesting stuff to talk about. And so I'm really, really happy to see this collection of sort of gnarly individuals up here. But there's other, Carl, Anushka, Billy, there's a whole bunch of other you that I think, sometime next year, I think this table is going to extend out another 6 feet or so. So again, so I would say, so one of the things, this is an experiment, we're doing this for the first time. This seminar replaced a 45-minute monolithic talk by me. So be honest and brutal in your evaluations. I think we want to keep the kind of interesting content ideas going. So just definitely let us know how it's going. Let us know what you think. And like I said, I'm excited. It's better to have more voices speaking less than a boring, aging white dude just sort of monologuing at you. So, all right. So I'm going to do the cloud sobriety stuff mainly because I tend to talk about what I'm doing as a consultant. And for most of the last 2 years, I've been really, really deep in a massive enterprise migration to Amazon. We're talking about a global multi-billion-dollar entity, and for the first time, I'm having to deal with enterprise workloads and enterprise considerations rather than just forklifting science or high-performance computing or cherry-picking individual workloads in. So because I've been knee-deep in the cloud for so long, I figured I could do some of the cloud sobriety stuff. So this slide here is just kind of outlining my own biases that influence the upcoming slides. A couple of basic truths here is that I really do start to feel like, the cloud questions, the easy days are over. We've done the easy stuff. We know how to screen our vendors. We know how to pick cloud platforms. In many cases, the proof of concepts, the workflow stuff, the easy days are over. We're tackling the hard problems now. The blunt truth, from my perspective, from an infrastructure perspective, Amazon is still kicking the entire globe's butt when it comes to capabilities and features. The caveat there being that Azure and Google are absolutely fit for use and they've been viable for a couple of years now. But if you're screening infrastructure clouds, in particular, you're weighing your vendors based on the sheer number of features, services, and the rate of innovation. It's not even close. Amazon still has a multiple-year head start on just about everybody else in the world. And the other sort of blunt truth is, I do admit that I work plainly in the enterprise and commercial space. I haven't seen or touched an OpenStack environment in years. The POCs have dried up and blown away. The vendors are still talking about it, but I just don't see it at my customers. So the dangers are still generally there. If it's still easy to waste fantastic amounts of money, the people who are wasting the biggest amounts of money are the people who are led by those executives who sort of excrete the words cloud first onto a PowerPoint slide without actually doing any due diligence or research or even math. The amount of money you can waste on the cloud is phenomenal. You're talking six-figure sums a month easily if you've got a mismanaged or poorly applied cloud environment. And so I think because of that, I alluded to this last year. There's some stuff I really can't sort of talk about in public, but you are going to start to see cloud pullbacks. And this will be because we have the actionable data, we have the billing data, we know the true costs. We now are in a position where we have the data to figure out which workload to run on-prem, which storage to keep on-prem, and which stuff to run in the cloud. So you'll start to see some sort of major migrations. I still think the interesting thing is the cloud pullbacks are not necessarily going to go from public cloud back to on-prem. There's all sorts of interesting public-private co-location facilities. Government supercomputing sites are trying to become revenue neutral. So I can actually see workloads coming out of public clouds and going to like NCSA iForge or TAC, or maybe a bunch of life sciences people in Boston ganging together and putting a bunch of shared stuff in like one of the Markley data centers or one of the sort of common gathering grounds for IT infrastructure in the Boston area. The other thing I'd mention is that it's relatively rare that I get a chance to build a cloud environment new. Most of my consulting work these days is existing cloud footprints that need new capabilities, new services, or need to be fixed. We're sort of past the days of bootstrapping entire companies into a cloud footprint. It feels like, we've hit that peak a couple of years ago. The last point is important. You guys know me, if you've seen me speak before, I'm pretty cynical and crusty, and in particular, I hate when vendors play fast and loose with the truth. We saw that happen with HPC. We saw that happen with grid computing. We saw that happen with petascale storage. It's now happening in the third-party ecosystem surrounding cloud. There are vendors who should know better, like Red Hat, who are being fast and loose with the truth. So you need to sort of prove out and do the due diligence on, particularly in the third-party ecosystem. Don't trust the pre-sales marketing material. You have to trust, trust but verify, I think is the word to say. And like I said, you'd expect it from kind of the small fly-by-night shops, but there are very large established companies that are towing the line of proprietary in many cases. So I'm going to skip this solve things and go quickly right into sort of what works. All right, the infrastructure platforms have been fit for use for a long time. I actually don't feel the R&D and scientific workloads are all that hard anymore. There's technical challenges, but we've been putting scientific workflows and individual cherry-pick stuff onto cloud environments for a very long time. The issues now are data management or data movement. The technical bits are largely solved. I think data, not metadata-aware storage or data management, that's still an unsolved problem, but the act of ingesting, moving, and exchanging large amounts of data feels a little bit like a solved problem. With the right set of tools, it largely comes down to the speed of my pipe. There's not a lot of technical barriers these days anymore, aside from maybe cost and the size of my pipe. I think the securities question is really, really interesting. From an infrastructure perspective, the building blocks are there. I can build an environment that is encrypted as secure as I want. It's still a pain in the ass to do it. It's hard. It requires expertise. monitoring the compliance and monitoring the state changes is a little bit harder, but I think from a security perspective, the building blocks are there. It's been a long time since there was a fundamental security or encryption or key management capability that I really needed that just simply didn't exist. I think the building blocks are there. And then finally, one of the things I've noticed is that when you read the kind of cloud propaganda, everybody talks about sandbox and dev test and all these, what's the first thing you should do to move to the cloud? If you focus particularly on Amazon, I'm starting to feel, based on my enterprise work, the lowest hanging fruit is relational databases. Moving your relational data stores into a managed services on Amazon or something like that, the ROI is almost instant. And starting to work with some of the layered stuff like the database migration service and everything else, I'm starting to feel that for a company that is just getting onto the cloud, dumping those relational data stores into a managed services environment where they're clustered, they're highly available, you've got read replicas, you don't have to care about backups. They can restore point in time, any point back in the last 15 days. There's a lot of crazy operational stuff that is just simply fixed. And I'm starting to feel like databases might be one of the overlooked low-hanging fruits right now on the cloud. So I'm going to talk about some of the mistakes and what's still really hard. I refer to these as extinction level errors. There are absolutely situations where you can get into where it makes sense to blow up your cloud environment and start fresh from scratch. The vast majority of them have to do with getting the network bits wrong. I won't read the list here, but I will say if you have any one of these problems on this list, you are better off, rather than incur a technical debt by creating workarounds, there's multiple environments where you're simply just nuke the thing, rebuild it from scratch, and move on. And it generally comes down to either network design or VPC or interconnections to the various cloud environments. If you get that wrong, blow it up, start fresh, move on. It's just too hard to fix and move around. This is just an example. One of the nice things on, in Reddit is monitoring the different cloud subs is this is an example of, an extinction level event. You stand up a VPC, you stand up your Docker bridge, and the Docker bridge uses the exact same subnet as your VPC, which means all network communication completely falls. You can't route, you can't talk to the internet. This is an example. Blow the VPC away, pick a new pick a new IP subnet range, install Docker, move on with your life. The other thing that's happening is it's very easy to talk about least privilege security, and the cloud gives us the ability to do fine-grained security controls that are just amazing. This is one of the areas where the cloud capability far exceeds what we can do on-prem in an enterprise environment. The problem is that the talk doesn't necessarily match what you can do in the real world. At the end of the day, all of this role-based access, this least privilege model, if you take it to an extreme, it's individual security policies for every employee, every software application, and every server, and that simply doesn't scale. Really what it comes down to is you're going to end up devolving into kind of a hybrid compromise solution. The single biggest mistake with the security model is baking in a rigid security model on day one. Security is always changing. You always have new methods, new tools, and new technologies. And so the biggest thing you can do is build into your cloud plans and cloud operational practices the ability to change up, alter, and sort of refresh your different security postures. I've lost count of the number of times we put all these rigid controls in place only to have them blown away by day 2 or day 3 as sort of the real world, hits the cloud environment. I'm going to skip the perimeter security stuff, except to say my single biggest beef with Amazon right now is you can't use the cloud features, including Amazon's APIs, without talking to the internet. That is a real problem if you're trying to build a hard shell environment. The solution is what Amazon calls VPC endpoints, but they've only got it for S3 globally and DynamoDB in a couple of regions. We really, really need to build isolated, secure cloud environments that can talk to the cloud APIs without going out on the internet. And that's just a major operational hassle for us right now. It's solvable, it's just a pain in the ass to deal with. The other big issue is that cloud capabilities are so big and so large that you have to bring a lot of people to the table. However, when you bring a lot of very senior people to the table who don't know a lot, you end up with having improper suggestions or improper designs that become baked into your cloud footprint that get hard to fix. I'm not going to read the slide here, but the problem is that every single one of these stakeholders belongs at the table, but if they're not fully trained up on the cloud capabilities for the vendor that you've talked about, there are very, very nasty repercussions or just ill-advised suggestions that are going to end up in your design. The other thing that I'm starting to run into, and this comes into like serverless and Lambda and Athena, is that there's a lot of organizations that are very process bound, and they have a culture that assumes a server exists, a configuration database exists. There are cloud capabilities, particularly the server stuff, that just have no native on-prem ortholog, and that causes an institutional hard stop, particularly when all of your documentation assumes something has a host name or has a configuration database entry. There's a lot of sort of operational issues dealing with the serverless stuff that are more cultural related than technological related. It's becoming a hassle, particularly in the larger, older legacy organizations. Cost optimization, like I said, we have the data, we know how to do it. The problem is that it's incredibly difficult to analyze. The third-party ecosystem tools for monitoring cloud spend and optimizing your spend, they're getting better. They're still difficult to deal with. A really great recent write-up within the last couple of days is this URL down on the bottom. Just read it to cover all of the gory details this one company had to do to sort of cost optimize. The payoff is they save $1 million a year in OpEx. So it's worth doing, but the engineering that they had to do was incredibly difficult, and it's not something you typically think of early on in your cloud design process. All right, I've got a minute left. I might actually finish vaguely on time. All right, so my hardest problem right now when it comes to cloud and enterprise has nothing to do with technology. The hardest part is dealing with the cultural and sort of bureaucratic IT procedures and mapping them to the cloud where things are elastic, agile, where we've got servers that are disposable that might only live for a couple of minutes. It's actually, the hardest part is the sort of cultural cat herding to change documentation, processes, configuration management, security reviews, that's like that, to sort of take advantage with the fact. And the problem is that if you don't adapt the organization, you lose a lot of the cloud benefits. You can't use elastic stuff on the cloud. You can't use auto-scaling. You can't use disposable stuff. You can't use serverless infrastructure because your org simply is not capable of dealing with those weird paradigms. I've got a couple examples here. I think for time reason I won't read them, but issue number one, if you're using a provisioning middleware, there's a lot of tools that will build cloud infrastructure for you. If it takes 6 months for your provisioning middleware to take advantage of the latest Google release or Amazon release, you've got a problem. Your users are going to be mad or upset. If your provisioning requires a human being to sign a piece of paper and shuttle it around the organization, you lose a lot of benefits of the sort of deploy in minutes, and you're back to sort of deploying in weeks or deploying in days. Not a big deal, but I think really the point that I want to get across is that unless you fix the organizational stuff, you can't benefit from the major cloud advantages. You lose a lot of that agility, elasticity, and ability to sort of react relatively quickly. I've just got a whole bunch of examples here, and I think for time reason, I'm not going to do it. One of the big ones when it comes to time wasting, though, or money wasting, is this middle bullet point here. Legacy IT architectures assume a 1-to-1 ratio between application server and application. It's really easy to forklift that. It's actually darn easy it's the lazy person's way to do it. The end result is you're just wasting tons of money. You have to sort of combine the forklift approach with, all right, how can we refactor, how can we architect to be a little bit more sensible in how we do things. All right, so finally wrapping up, in terms of real world, we've seen some assumptions about this. I know Chris talked about it in his talk earlier. For me, multi-cloud is starting to be things like, I think identity is going to be in Azure AD, or identity might be Office 365. And I think my business processes in science are probably going to run in a mixture of Microsoft, Google, and Amazon environments. So for me, multi-cloud is not applications spanning multiple clouds. For me, real-world multi-cloud is my identity federation lives in cloud A. My business processes are running in clouds B, C, and D. I think that, to me, is realistic multi-cloud in an enterprise setting. And then finally, I want to end this talk with things that I'm sort of excited about. If you stop by our booth or you've seen stuff, Amazon's new service, Athena, the ability to drop a file, a piece of scientific data into an object store and execute SQL queries against your random data in an object bucket. No Hadoop, no Elastic MapReduce, no Spark stuff. The ability to ask SQL-based queries against scientific data residing in an object store, no server required, no Hadoop required, is game-changing. You're going to see a ton of interesting Athena-related stuff coming out in the future. I'll skip the BioTeam skunkwork stuff, except I'll say the other two things I'm excited about, we talked about iRods and metadata management. Starfish, if you guys have seen the Starfish booth, I should congratulate them on their Best in Show awards. Starfish is something I'm really, really interested in getting hands-on with. And then the other thing is Singularity, I think, is also in the sort of top of the hype curve right now. But in terms of container-based handling of scientific information, Singularity, I think, seems to solve a lot of the pain points that kept me away from containers and Docker stuff for quite some time. All right, that's it. I am all set. Thank you guys very much. I think we have a few for questions.
So I'm going to go ahead and ask the question that is at the top of the list right now, and you kept hitting on it. It's if the organization needs to shift in order to take full advantage of the cloud features and architectures and re-architecting and everything, who within the organization can the CEO hold accountable for the infrastructure, which is now this multi-hybrid cloud thing? How does that work in the best run places?
It's kind of funny. I think IT should be responsible for the guardrails, the security, the operations, the tagging, and the cost management. I think the responsibility of infrastructure devolves now onto the users, the scientists, and the individuals. So I think the role of the cloud in the future is it's our job as IT people to construct the safe guardrails, to provide all of the training training and resources, but we're actually giving the keys to the infrastructure to the users. I want my users to turn on machines. I want them to turn off their continuous integration server at 5 o'clock on Fridays to save money. So I think really the short answer is IT is responsible for operations, security, guardrails, cost optimization, all the boring stuff, and probably compliance and monitoring, but responsibility for infrastructure devolves onto the user. I think that's where we're going to see it.
Questions from the audience?
I'll skip on to the...
Questions from the panel?
We just really want to throw the catch boxes at you, so ask questions.
All right. Well, if there aren't any questions, we'll just move on. Keep sending the questions to slide.io. We built a lot of time into the schedule to sort of keep this thing interactive and to keep you guys from falling asleep. And,
Actually, I'm going to pin you there for just another
Okay.
sec.
Yep.
This is such a rubber meeting the road question.
Yep.
Is MPI at end of life?
Wait, say that again?
MPI.
No, all right, so MPI is not at end of life because we probably have 8 or 9 years of computational chemistry and molecular modeling software that will still continue to run it. And so I think what you're going to see is a very, very long tail. We'll be running MPI. Now, the real issue is whether or not there will be a lot of new MPI codes written or whether the new MPI codes that are being written are latency sensitive. The big issue in IT is, do I run MPI on very expensive low latency interconnects like InfiniBand? For chemistry and molecular modeling, absolutely. For bioinformatics and computational biology, the stuff runs just as well on Ethernet as it does on InfiniBand. So actually, the short answer is, yeah, MPI is going to be around for at least 8 or 9 more years because we've got a huge legacy code base.
Same question for HPC schedulers.
HPC schedulers, until we have everything that always has a RESTful API everywhere, HPC schedulers are going to be around for a long time. I'm doing less and less grid engine consulting and less grid engine training as the days go on, but we're still building grid engine into Amazon. Amazon has recognized the business need, and they now have Amazon Batch. So I think traditional schedulers are going away, but again, it's long tail, 6, 7, 8, 10 years probably.
Okay, so if you had to make a bet and pick one.
Pick which one would die first?
Which one's going to live? Which is your favorite child?
Honestly, I think MPI might live longer because the whole process of HPC schedulers is just task distribution based on a resource allocation policy, and there's probably a dozen different ways we can tackle that problem. So I think someone's going to come out with a better scheduler, and someone will come out with a better way of distributing tasks according to a policy. So I think if you pin me to it, cluster schedulers will disappear faster than MPI and message passing interfaces.
I would add, too, that I think for microservice orchestration, cloud and multi-cloud, that's actually going to move closer to messaging and events and MPI. And the new MPI that we always waited for decades may actually emerge out of all that.
There's whole new realms of scheduling that need to be created at this point. Yep. Cool. All right, I think we're still on time.
We got one question.
All
right. Nice.
Nice.
Okay, so this is a little bit off track, but I think this is a really important question. So we've heard a lot about how unique these technologies are, in particular how unique these millennials seem to be in terms of driving innovation, et cetera. So my question is, when it comes to the people who are unicorns in these industries, in these companies, right? How do we actually make them to be less unicorny? We get more people with that mix of skill sets and stop treating this kind of stuff that we're talking about here as really novel and special and shiny and brand new.
I think BioTeam people have 8 different answers to that question, but also my take is my particular pet peeve really comes down to sort of education and training and discrimination against an aging workforce and things like that. And really what I come down to is unicorns are very, very expensive to hire, maintain, and trait. And unicorns are in heavy desire. They're being hired across industry. I'm a huge fan of solving the unicorn problem by investing in my existing workforce, additional training, existing certification, knowledge transfer. BioTeam has a huge, there are multiple success stories from taking young kids and training them up and having them turn into unicorns, but you can also take long-time employees, retrain them, reskill them, and again, you get unicorns out of it. So I think, for me, the answer to the unicorn problem is invest in the workforce and train up your internal people, because the unicorns are going to be, the unicorns can walk and go anywhere, and they're expensive. It's better, rather than buy or hire the next unicorn, you should be growing the unicorns in your organization.
Yeah, and just to quickly follow up, I think I totally agree. I think the actual problem is that a lot of the stuff we do has no formal training in the industry, right? HPC, there are no HPC certification programs out there, right? You just happen to learn it if you happen to work in that environment. Same thing with large scale high performance performance networking and things like that. And so this integration pattern is really, really hard to find. We know because we try to hire them, right? And so the other thing though is that I think the thing that the workforce does not identify, or at least the hiring process does not identify, is implicit talent. Right? Talent, the thing that you're born with, what can you do? Are you curious? Are you self-motivated? Do you want to expand your learning beyond the walls that have been put up around you? Those people are much easier to train in this than the people who aren't, right? And so that identification, I think, would come out by formal training as well. So.
I've seen practical implementations of this in several companies, and sometimes it's mandatory shadowing of someone in another department, so it's not left up to people. There is a policy that says 3 months out of a year, you are not doing your job. You're in another department, following someone, helping them to the degree that you can, and then you come back to your old job. That's just one example that I've seen that works.
Yeah, don't let your unicorns kind of stay in the high tower away from everyone. Yep. It's proximity. So you take a bunch of ponies and put them in proximity with the unicorn. That equation equals more unicorns. That's what I had to do.
What about donkeys?
And I would lead on this a little bit as well, because as consultants, when we get hired, it is frequently, because you have a process that requires this particular person. This particular person is the only one who knew exactly the right triple of skills. Well, as a senior leader in an organization, look out for that. That's a flawed organization. Yep. If you find yourself needing to hire only people who are very, very difficult to find, well, staff rotations, yes, and different ways of building tools, too. The whole, DevOps, Agile can then bring the entire team together horizontally, coupled with a strong practice of staff rotations. I don't think we should have the cult of the single person who's brilliant, who's the only one who can do it. I think that we should make processes that are runnable by humans.
By the way, the guy who asked that question is a unicorn. He's.
I don't want to be the only unicorn. I want all of you guys to be unicorns.
Thank you, Chris.
I can't follow that, by the way. All right, and now for something completely different. So I've been really thinking a lot about leadership and this idea of extreme ownership in bio-IT or in converged IT. And I think as leaders, we have to take ownership of everything that impacts our scientific mission, right? So in bio-IT, I think this means taking ownership of the network and how it performs, the security, the infrastructure, and how it all comes together to support the science. So great leaders accept full responsibility for failure and aren't interested in taking credit for the success. So I kind of believe that there are no bad teams, there are only bad leaders, right? And this applies at all levels of an organization, from senior level to junior level, teams within teams, okay? So hopefully these kind of principles broadly apply to you. So I've always thought of BioTeam as Navy SEALs. I don't know why we used to say that. We're probably more like an Army or something now. But I still identify as Navy SEALs, right? And I think the origin of the SEALs is kind of interesting. So in World War I, the military was losing a lot of Marine and Army troops due to failed beach landings, right? So the Navy had kind of realized that they had to clear the beach so they could provide, defense on the coast and get the Army on land, right? And that was kind of tricky to do. So they initially formed this underwater demolition team. And this was the first time the Navy actually bridged the gap between the water and the land, okay? And so they saw this new need for unconventional warfare going into World War II. And science kind of requires, unconventional IT, right? We have special IT operations, the unicorns we were just talking about. So what we really need are T-shaped systems engineers, people who can go broad and deep, right? And in close proximity to the science. So I like to force analogies down people's throats. So let's take, the data is obviously the sea. It's the data lake, right? Data is vast, and data is apparently wet. And air is the infrastructure, right? Because good infrastructure should just be invisible, and it's everywhere, and we also need it, right? And then science is like the land, and I consider the scientists like the ground troops, okay? And so we've heard, over the past couple of days of all these huge challenges that we face, right? And everything is really hard, right? And I think the answer is just in building really high performance teams, like we were just talking about. Teams that engage in unconventional ways, they bridge the gap, they aggressively remove roadblocks. They are best practice, right? And they're diverse by their very nature. So, extreme ownership is about making no excuses And I think these are the kind of teams that we have to try to build to solve the problems in this space. So it really starts with winning the war within, right? It's you against you first, right? And so strong leadership really starts with believing in the science. And you have to understand the why. Why am I doing this, right? And, Chris used to say you can't just tour the lab once a year. You actually have to sit side by side with scientists and understand what they're doing. You have to ask why until you understand and interrogate this, environment. Do root cause analysis. Understand how scientists are problem solving, right? And so I also think incentive is really important, right? You have to be able to answer that question, is it worth it? Is what we're doing worth it, right? And if you can't answer that, you're going to have really a big problem, aligning up and down the chain of command. So implementing extreme ownership really requires checking your ego, right? Who here doesn't have an ego? Ego, clouds your judgment, right? And, the ego hates trade-offs. Your team should operate with a high degree of humility, taking on the challenges that other people don't want to, okay? And I think that's why we're all here, right? Like Aaron said, these challenges are great, and this makes this space great, Zen Buddhism has this concept of, the beginner's mind, right? This attitude of openness. You're eager to learn and you're eager to lead, right? And I think that's what really separates people in this space. You're eager to lead and you also have a lack of preconceptions, So it's attitude and mindset. I think that's what we were just talking about. These are really important when you build teams that support science, mindset and attitude. You can't be too good to fail or afraid to fail, really. People like to say failure is not an option. That's bullshit. Failure is an option and it's just learning, right? A good example of ego getting in the way is, what I like to call big data envy or high performance envy, right? And Aaron talked about this. It's like building some giant Hadoop cluster for an analysis that could have probably been done with a multi-threaded Perl script, right? Just because Facebook or Google does it that way doesn't mean that you should do it that way, right? Solve your own problems. So another leadership principle is simplicity, right? For some reason, people really like to buy complexity. But the simpler you keep your planning and your overall strategy, I think the better your outcomes are. Complexity looks great on diagrams and on feature lists, right? But it really hurts when things start to go wrong. And the plan should be understood by the lowest common denominator on your team. Otherwise, it's a non-starter, right? Your team should feel free to ask questions until they understand, right? Simple planning is easier to adjust in a rapidly changing environment. So oftentimes solutions are too complex. I think we should be thinking about power to weight ratio and what that means in hardware and software and things. How can we be lightweight, flexible, and powerful? Did I skip a slide? No. All right, so DevOps really needs something like decentralized command. SEAL teams are known for this. They assemble fire teams, which are just building blocks of 4 to 6 people max, right? One person can't manage 25, 30 people. It just doesn't make sense. You have to empower junior leaders to make decisions and take initiative. You can't constantly check in with everyone. So this requires simplicity in your planning, otherwise things will spiral out of control. And it relies on more than just a mission statement. Everyone has a mission statement. You have to understand why. Don't let them ask, don't tell them what to do, right? Have them tell you, this is what I'm going to do, right? And it's tricky, so let them adapt. And again, take a look at an org chart, Does it even exist? Is it current? Is it clear? And, are regular folks even allowed to see that, right? It's kind of interesting. So, this idea of discipline and freedom are kind of opposing forces that have to be balanced, We can't be so rigid in process that we can't adapt. And good leadership is about, making rapid decisions based on the situation. Every situation's unique, will inevitably change, so you got to be swift and ready to adjust. Another example is, choosing a configuration management system. People will fight for years over Chef versus Puppet versus Ansible, whereas if you had just picked one and went, you'd be way ahead of the competition, right? So don't spend time waste time over those decisions. So every DevOps journey is unique. It's not about technical change. It's about a change in our culture and the way that we work, solving your own problems, like I said, trying new things and failing, not being afraid to fail, sharing your experiences, right? People talk about tools, but I don't think tools are that important. They all suck. Some suck less. And DevOps isn't just automation. It's people and processes. And you can't just create a third silo. You can't create a DevOps team that doesn't talk to any of the other teams. That doesn't make sense. You just created a new problem. So really effective DevOps requires that kind of discipline. A team that has disciplined procedures, the more freedom they have to use things like decentralized command. And there's always that temptation to kind of take the easy path. But we have to consider, long-term strategy, even if it takes more time, right? We have to make time, get up early. Working ad hoc and being lazy about your process is really not an option. Standardizing and agreeing on fundamental procedures are key. How you start projects, how do you finish? How are you going to communicate, right? This stuff matters when things start to go south. So you really kind of fall back on those fundamentals. And when those fundamentals are really solid, now you have all this freedom to be creative within that framework. So this might be stupid, but I'm starting to think that real networking in IT is kind of like wrestling in martial arts, okay? Especially wide area networking, because networking is like really hard. It requires hard work. You actually have to dig like real trenches in the ground and break through brick walls, like literally. And most things in tech really aren't like that, right? So networking is very intimidating to people. I find this very interesting. We interview and talk to a lot of people, and networking is one of those things that people tend to be really weak at, and they're also really afraid of, So like simultaneously, everyone's afraid of it, but they also wish they were better at it, right? So how many people are like, man, I wish I had experience with BGP routing and Bro and 100 gig switching, right? Everybody wishes they had that experience. Just like in martial arts, everyone's like, man, I should have wrestled in high school, right? That's what everybody says. So you don't relate to that, but I do. So anyways, it's, and networking is also like really simple in theory, right? It's got like straightforward physics, bits, bytes, packets, easy to understand, and then it gets really complex in the real world, right? Just like wrestling. Anyways, so let's look at a few trends. One of the biggest is evolving VPCs and network designs. Just like I said, networking is a big deal right now, and the evolving network design in the cloud is getting interesting. So a few years ago, this is what VPCs might have looked like. A single region with a couple subnets, life was good. But we finally had advanced networking options to connect our on-premise network, and so this was all great, right? But networking, the cloud today is looking like this, right? So the success of those early environments pushed us into more complex scenarios. This is what VPC might look like now. And in these environments, IP planning, routing, all the stuff Chris talked about becomes non-trivial, right? And these highly connected environments require engaging with enterprise network teams and making tough decisions about firewalls and equipment and procedures and ownership, right? It's all about ownership. Again, some of these folks are the same people that are riding Cisco certifications and can be pretty smug about cloud, but we have to work with these people. Otherwise, we're really not going to get our jobs done. So, DevOps should be about sharing and evolving best practices, and I think, codifying your best practices allow you to kind of define your infrastructure DNA. I won't talk too much about this, but we like Terraform, and I think tools like this allow you to, manage your infrastructure as code, publish best practices. I'd like to see more of this stuff, but in scientific computing, sharing best practices, sharing infrastructure recipes and templates so that we can all kind of raise the level. I'm really getting tired of the phrase infrastructure as code, so I decided to kind of create a new one here. So, what about, infrastructure meta-programming or like meta-infrastructure programming, right? The idea that you have code that writes code that emits infrastructure, right? So it gets pretty meta, I think, and I think this is maybe where things are going. So you might have code that creates templates, inputs to templates spawn infrastructure. So there's not this one-to-one relationship. People say infrastructure as code, but it's not one-to-one, right? You have one template that's emitting new environments constantly, right? So that's kind of interesting. I think in those environments, we can encode the compliance, right? We can have infrastructure that's, self-policing and self-modifying, right? So I think that's really interesting, and I think goes beyond just saying infrastructure as code. It's something a little more. I'm not sure what it is, though. So again, people wanted to talk about functions as a service. I'm just going to breeze through it. It's here to stay. It's enabled some really cool stuff right out of the gate. People were jumping all over Lambda. And really, again, it's just a byproduct of hyper-converged infrastructure. You get to run your code on the same platform as the storage. Lambda's pretty amazing. I won't say too much more about it. We'll talk about it later. I think you can do all kinds of things with this: genomics workflows, metadata extraction, QA and compliance checks, data transformations, all kinds of really cool stuff. So I like this idea I heard at reInvent of chaos engineering. Netflix really talks about this and puts out a lot of open source. And it's the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. Right? So the idea is that you build some large distributed system, then you find creative ways to try to break it. Right? And each time it breaks, you learn something, and then you run more experiments. And so some might call this robustification, which I don't think is a word, but I think Merle Giles from the NCSA said that. I like it. So robustification, or uncovering weaknesses, finding holes in your game. It's an inoculation against failure. And I think it's really interesting. And you'll find things in these failures like retry storms and cascading failures and new single points of failure. You have these interesting cloud effects of like internal DOS attacks that happen when certain things go down, right? It's really interesting stuff. You can simulate this and you can experiment around this. Netflix has a couple cool open source tools. Chaos Monkey randomly terminates EC2 instances in your environment. I'm sure you've heard of that. But you might have not have heard of Chaos Kong, which just nukes an entire AWS region and you have to evacuate, right? That would have actually inoculated a lot of people against the East outage, but nobody was doing it, right? And then, Latency Monkey is cool because you can inject random latency between all of your microservices and see what happens, right? So I think that's really fun and interesting stuff. And so, every talk has to talk about culture. And we talk about BioTeam as a company, but companies are really just ideas, right? And so BioTeam is just an idea that I think represents the highest standard of IT supporting science, bridging the gap, holding ourselves to high standards, and then putting it all together with hard work. So, last year at this conference, someone called DAG a superhero, and I think to a lot of people, he is a hero, right? Because in nature and physiology, pain trumps everything in nature. So therefore, any attempts to alleviate pain trumps everything. And so a hero isn't somebody with superpowers. It's someone who fights through the pain so that someone else doesn't have to suffer. And so I'm realizing BioTeam is kind of like a cult, but a cult of love. Love for science, and love for science with the determination and the firepower to get it done. It's about going beyond, just compassion for science, right? It's, your happiness is my happiness, like truly. Like, let's collapse the duality mindset. It's not us versus them. It's, all of us together. So, all right, that's it. Thank you.
Welcome to the cult.
You're all invited.
So we got a question that I really like, and it bounces into how to work with teams. The question is, when you're creating a platform, they pick data lakes as their example, how much of your starting point is the infrastructure that you either have or that you could have, and how much of it is who you are already related to in terms of vendor relationships, partners, on-the-ground expertise. You've got stuff that you could have, and you've got what people already know and who you're already close to. How do you balance those?
Man, okay, so the question is how to balance between vendors you're already using versus
do you start
what
with
you
the
want to
best
buy?
tech, or do you start with the technology your team already knows?
Yeah, it's kind of like getting back to the unicorn thing, I guess. Like, do you kind of build people up into these specialized roles? Yeah, I don't know. I think roles and stuff kind of can go away. I'm more interested in people that are building tools and building new things. So, yeah, I don't know if I have a good answer other than build good teams, and I think they'll figure it out. That's a cop-out.
I'm going to
Someone else jump in, please. Yeah.
I'm going to quote Dune on this one. Fear is the mind killer. Right.
Yeah.
I think that's actually on my last slide, or something related to it. But the thing is, we shouldn't be afraid of things, right? I don't think there's any use in saying, but we already know this, and we can force this to do this. It's going to take a lot more effort, but we can force this to do it. Why not take the adventure of learning something new and trying something new? And it's that fear of failure that prevents everybody from doing that. Versus try it. It's okay if it doesn't work, right? That's an opportunity to change and innovate and level up your team in a way that makes you more extensible, more cross-functional. So that's my feeling.
I'll be slightly contrarian and say that I think there's a tremendous value to institutional knowledge and incumbent vendors, products, and technologies. So I think they win the battle in the default sort, and then you move away when your business, science, or technical requirements preclude. The specific example in BioTeam is there's a lot of reasons to use networking vendors other than Cisco, but there is a tremendous built-in skill set, knowledge base, tech base, where the barrier to switching away from a vendor like Cisco is really, really huge. So it's easy for consultants to be glib about that, but in the real world and enterprise, it's a difficult choice. So I think for me, the default choice is incumbent knowledge, incumbent vendors, incumbent products, and you switch when there's a business, science, or technical reason to do so.
Yeah, and that is a hard thing to balance, the curmudgeon versus the person who's in infinite awe of the new things, right? And so you kind of have that dichotomy there. But it's basics, right? So basics still work. And so I think you can always try new things and then bring that back into what you already know. So I don't think trying new things throws out the old stuff, right? I think it just adds to your completeness of what you know.
That's perfect. And I mean, I was going to say you can fall into a pit either way. I actually think neither apply when you're considering this. It's an engineering question of, do you have an elegant engineering solution composing together, I guess, for your platform or what have you. If you have institutional knowledge and experience, great. to Chris's point, that's a path of least resistance. I actually think you could quantify that as an engineering consideration. But if you, just have things that you're trying to shoehorn together, to Ari's point, that won't lead to the best solution. I think we're in a world right now where, as we're all connected in a community, at the same time, we watch engineering solutions end up winning. So you have to consider that first.
Also, Cisco is not that crusty. They rename things all the time.
Nice.
Oh, was there somebody else?
Let's go up in the stairs here. Sorry.
I was just going to say, my answer to the internal, external is actually understanding the problem, because a lot of times what I found is going outside means that you're not understanding the problem and you're going out to over-engineer it. Or you're like, hey, that's really cool. I want that extra speed. I want the buzzword. I need microservices for this, when you're not building that, So it's a matter of correctly understanding your problem and getting your team to look at what the right solution is.
Yeah, understanding why, and it's going back to that, simple, right? Making sure it's simple. If it's simple enough for everyone to understand, you won't have a problem, right? When it gets so complicated that now, one person understands it, now you have a problem. So I think, keep it simple.
Right.
Hey, Adam, very good analogy. Thank you. Powerful and apt. That makes me very curious to know, when you start engaging with a customer, right? How do you go about the first 3 days in terms of maybe objective by the end of day 1, day 2, day 3? Not necessarily in technical, but just in the general approach.
Yeah, how do we, just sitting down and talking to people is generally the way we start. So, start interviewing people and understand what they're doing and why they're doing it and how they work. And then, from there, I think, depends on the goal of the project, but, looking at org charts and understanding the team dynamics is always interesting. Understanding who has, way too much on their plate, or who's, the super stressed people in the group, I think, kind of points out some failures. Yeah, I don't know. Anyone else thinking about what you do first?
Yeah, I mean, we really just, we take the approach of just getting to know you, right? Asya pointed it out very clearly, right? We start by asking a whole lot of boring and annoying questions, right? Some of them seem that way, but you'd be surprised. And so the other thing that we do is we really engage in conversation. And Adam said it. It's not about us. It's about them. It's about the collective, right? And so what we're trying to understand is your organization and what needs to change in order for your organization to meet its mission, and ultimately for hopefully everyone to be satisfied with that, right? The satisfaction is the hardest thing to get to, and usually culture is a barrier. So we sort of pay attention to everything from infrastructure to culture to all of that stuff, because if your organization isn't doing that, you're missing the problem entirely, right? Culture is just key to getting anything done. I think I've said this a few times, but you could put the perfect IT thing in front of everybody, and if the culture's not ready to accept it, the whole problem, it's going to fail, right? So,
I think we have time for one more over here.
No.
Oh, no? Okay. So with that, thank you.
Thank you.
you still have the lab on.
And in terms of structure, this is going to be the final talk with slides, and then we'll probably have a conversation like we just did that extends for as long as it needs to, or 3:55, at which point I'll ask for the wrap-up, and we are happy to hang out and talk as long as you want to afterwards, but that will be the 4 o'clock is the end point. So last formal talk.
All right. I have no idea how I drew the short straw to follow all this up and to be at the end and to bore you to completion. But I decided to pick something to wake everyone up and something that's absolutely certain to have pissed somebody in this room off at all times, and that's security, right? So depending on which side of this you're on, we'll see if this is interesting or whatever. So the real problem I think that we run into all the time is that we really need to do IT at the speed of science, right? And we don't. We do IT at the speed of like business administration, which is just glacial, right? On purpose, it's glacial, right? Web and email is not how we get science done, right? Floating Word documents around is not how we collaborate, right? And being super, super safe and secure is awesome, except that it's a myth, right? So we spend a whole bunch of effort, and people stake their careers and are incentivized the wrong way to try to protect us from incursion, and we end up in the process just killing the innovation machines that our companies are trying to move forward, right? And so basically what we need to do is step up IT sort of into a holistic model to support data movement, right? And so the issue, a lot of places that we walk into, most IT services are completely separated, right? We talk about silos all the time, silos of excellence, silos of failure, whatever you want to look at it as, right? And that's a problem, right? Network is not different than storage, is not different than compute, is not different than security, is not different than applications or policy, right? Those have to work in a continuum. That's why, I don't know who's seen Maslow's hierarchy of needs from psychology, but we sort of redid this for IT, right? In that, the fundamental thing that everybody needs for scientific computing to work well is the network, right? If that doesn't work, everything else fails, right? And then somewhere in between there, you've got infrastructure, storage and compute and data management sitting on top of that. And unless those three layers are correct, you can't effectively do tools and workflows. If you can't do any of that stuff and have the people up the side to support the whole thing, that pinnacle, the top, the shining hope at the end is discovery, right? And that's what we're all trying to do here, right? We're trying to improve human knowledge and improve discovery. And so without all these things working sort of in unison, you're never, ever going to get there. You can't think of them in isolation, right? So basically, I spend most of my time these days, trying to crash BioTeam into the ground, and then also working on networking as the main problem of things, right? So basically, science, first and foremost right now, it's a networking problem. Without high-performance networking, petascale is just useless. You have to move data. I don't care who you are or how you think you're going to move your analysis to the data, you're going to have to move the data at some point. And if you're anywhere above a couple of petabytes, your network has to be really solid to make that work, and any time that's not going to crash your productivity, right? Most orgs that we work with are well into the tens of petabytes. Most laboratories right now, and this is from Chris Dagg, need to be peta-capable, right? If one of your labs has a light sheet microscope or a cryo-EM or a couple of sequencers, there's a possibility that laboratory is going to generate a petabyte of data this year, right? That's a new reality that's way off the map. That means that your laboratories now have to be well integrated into your workflow and your IT infrastructure, right? 10 gig to the lab is pretty rare. How many people have 10 gig to the lab? I know there's a few. We're getting there, right? But that's kind of going to become a minimum pretty soon here, right? The biggest issue is that traditional enterprise networks were really developed for web and email and business administration, right? Thousands of really tiny workflows in the kilobytes to megabytes that just bounce all over the place, right? And the complete antithesis of that is scientific data movement, right? Nastia touched on this, right? Which is really a few very large flows in the gigabytes to terabytes range, right? And so those two things are completely at odds with each other. And so when you're trying to move large data and your network is developed for the lots of small little bits and also treated as a cost center to be controlled, yeah, moving single streams of large data just really doesn't work, right? And then also the security tends to squash it down, right? Because people put security in line because, building walls keeps things safe, as we all know, right? So the network becomes key. And so the result is that this becomes the most common high-speed network, right? FedEx is really high bandwidth and really high latency, right? And so they also have a reasonable dropped frame rate where they drop your hard drive, so pack them well. Literally I have had FedEx run over my hard drives before. So not to mention that doing data ingest from a bunch of hard drives that people copied onto from some USB connection somewhere and moving that onto your GPFS system, super annoying. Ask Amazon, they're going through this right now, right? So, and then there's enterprise security. Those of us who do enterprise security hate enterprise security. Those of us who are the victim of enterprise security hate enterprise security, right? It's just sort of universally hated, right? And the problem in enterprise security is that it's sort of universally applied to all use cases, right? The security environment is designed for the highest risk data in the network, right? that is just a complete failure in policy, in my opinion, right? Because usually the highest risk data in the environment is 1% of your data, right? So now you've taken a giant sledgehammer to your whole organization, driven productivity and innovation into the ground because you want to protect this little box over here, right? It's really the opposite of where things need to be, right? And so, and science today just simply cannot be done without collaboration and data sharing, right? If your security is so tight that you have to go through three weeks of background checks, fingerprinting, and go take 15 hours of training before you can have a collaborator come in and work with you, things are wrong. You're not doing science. You're doing, I don't know, dictatorship. I don't know what that is. So the thing is that security is very, very necessary, right? It's a real thing, right? But it can be applied pretty flexibly. So the bottom line is that I feel like it's time for security to evolve. We've moved beyond the sledgehammer, and honestly, so have the hackers, right? This is something that we really need to think about. I think this picture kind of exemplifies this, right? The security dude sitting asleep behind the cardboard cutout of the scary guy, right? That's kind of the way we've evolved to this, because we sort of throw firewalls in front of things and go, oh, we're safe, right? And no, you're not, right? And so, the interesting thing is that we have the technology and the ability.
Now it's really secure.
And the security has shut me down.
That was a clever hack, I have to say. Good job, whoever that was.
Oh, okay.
Oh, did the donk.
Just unplug it. It's
IT.
secure.
Sorry.
Is anybody here who knows IT?
Where is the slide? Oh, yeah, really, right?
It just shows you how passionate he is about the topic.
That's exciting.
Your laptop.
We had it before.
Yeah, I don't know where it went. It's weird. Oh, here, hold on. I don't know why this opened. Technical problems.
Google Slides.
Google Slides. It's our first time trying this, so you guys have been an experiment, and this is not going.
Reload. Yeah, it might be the network. Did the network go away?
Did the network just go down?
Here,
Sweet. We don't really have a backup. Here, hold on.
So can we?
Yay. All right.
Multiple copies.
All right, so I'm going to move from my phone for a minute while Reverend Adam is cleaning up after me. So it's basically time for security to evolve, right? Use security methodologies that are appropriate to the measures you're trying to control, right? To make it appropriate to the workflows you're trying to do, right? We do have that technology to separate the traffic based on what it is, right? We have a lot of intelligence in the environment right now that allows us to make those sort of decisions, right? A mouse genome does not carry a computer virus, all right? And it's huge, right? You don't need to inspect every packet for a computer virus in a mouse genome, right? You're wasting a lot of time and a lot of effort by doing that, right? If someone, and the truth is that if someone really wants your stuff, I sort of said it earlier, they're going to get it, right? They're going to get past the firewall, right? And so, you need sort of a last line of defense against your data, right? We getting there? Oh, sweet. Maybe we can just mirror.
Yeah, it's not projecting. Yeah, go ahead and mirror.
Okay, I don't need my notes. Oh, and that's over there. Awesome. Trying. Arrangement. Good.
There we go.
There you go.
All right.
Yay.
Oh, come on now. Seriously? All right.
Can you advance?
Yeah, sit down a lot. All right, we're good.
Now we're going to review everything, okay?
Remember this? All right.
Yeah, this is like last year.
Yeah. This is Chris's regular pace. Yeah.
All right. Here we go. All right, so this is what I was just talking about. So basically what we've done is evolved how we approach networking in science, right? We have the Department of Energy to thank for this, the concept of a science DMZ, right? And this is kind of what a science DMZ looks like. Those of you who came to my talk yesterday, I talked about this rather extensively. But the bottom line is that the enterprise simply isn't agile enough or capable enough of handling your science data, and so create a new network. Okay? And so if you move the whole science enclave outside of your network, so that cloud there to the right there would be sort of your site or campus or location or whatever, the enterprise, outside of that into what's called in networking parlance the demilitarized zone, which is a little bit unfortunate, but that's essentially what it is. And it's outside the company firewalls. Okay, what that allows you to do is to redefine the security model that you're operating in your science environment, right? And it also allows you to architect this type of networking in a very fast and very clean fashion, right? The point of this is to move data fast and cleanly and to reduce the barriers to science getting done well, right? So this is obviously the most simplistic model of this possible, right? The problem is that, well, and so one thing you'll notice here is that there's no red firewall between the outside world, the wide area network, and this environment, right? There's good reasons for that, which I'm going to come back to, right? The thing is that firewalls, this is my birds and the bees talk about firewalls, they don't work like you think they do, right? They're not these magical boxes that just sort of make you secure, first of all. If you use them right, maybe they are. And they have a lot of really, really cool features, and they're awesome for the enterprise. But the problem is that most firewalls are composed of a set of processors that are lined up in parallel that inspect and analyze your data through ASICs, right? Automatically programmed things that respond to policies that you program into them. And so that's what they look like if you break them out on the right. You might have a 10 gig firewall, and it can say 10 gig on both ends. But inside, it's actually a bunch of digital signal processors that can only function at 1 gig at a time, right? And each one of those locks to a TCP stream. So if you're sending multiple terabytes of data through something, and you've got a 10 gig network, and it's going through a firewall, you're probably only going to get 1 gig out of it, right? And so this is something that most people don't understand about firewalls. A couple of new firewalls really actually do this at speed, up to 100 gig, but you're really going to pay for them, right? And so this is an excellent fit for the enterprise traffic profile if you think about it, right? This is architected specifically to handle the many small flows problem, web and email, documents, quick requests to things, right? That fits this model really well because that parallelizes in batch. Right? It's an embarrassingly parallel problem, right? High performance data transfer is not an embarrassingly parallel problem because you can't split it up like that, right? So it's time for an alternative network security model, right? Which the science DMZs have been implementing for a while now, right? Again, clean network paths are the way to go. If you look at this diagram and you think about what a firewall is, NIST, the National Institutes for Standards and Technology, sees two firewalls. Right? There's the actual firewall with the word firewall string on the side up there in the right-hand corner. And then there's the thing at the middle, which is a switch or a router, which really does access control lists and port filters super effectively at full speed without dropping packets, right? And if you know anything about TCP/IP, which we all use every day, drop packets are the death of your wide area network, right? It drops off so fast that it doesn't matter what you do. So really what you want is a relatively lossless environment. And so every time you put a firewall in the way, every time a processor gets busy in the firewall, it's going to start dropping packets because it's in line, right? And that's going to slow everything down. So I think I talked through about all of this. So basically, when you use the newest network hardware as sort of a stateless firewall, because the reality is that what do you get for having a stateful connection? You get application analysis, right? That's what everyone's really looking for. Let me inspect my Word files for viruses. Let me look for malware hiding in email streams. The thing is that none of those are programmed for BAM files. Right? None of those are programmed even for large image file types, right? And so the processors just sit there and churn on it and don't ever get anything from it. So why not exempt it, right? And so the interesting thing about a science DMZ is that you can basically, you can restrict, so the difference between a science DMZ and an enterprise, aside from the performance matrix, is that you have a much, much smaller set of use cases that you're accessing there, right? Scientific analysis, scientific data movement, scientific storage. That's what you're looking at, right? You're not having people browse the web. You don't have, desktop sitting in there. People aren't going to YouTube. People aren't looking at cat pictures, right? They're using it for science, which means that essentially at the border, you can restrict the hell out of that thing, right? You can put access control lists that only allow access to externally facing surfaces coming in, and you can limit your TCP ports to something that is, you need to let Globus through, right? You need to let SSH through, right? But other than that, you don't. So what that does is shrink the universe of what people can attack you of down to this, right? And really reduces what a firewall really needs to do and makes it much more defensible, right? So the other thing that you do here is that if you look at sort of a more blown out view of what a Science DMZ is, the other best practice from Science DMZs is to use an out-of-band intrusion detection system, right? The one that's most commonly used in this environment is from Bro, right? Hey, Bro. And it's, it's the Bro performance monitor, or sorry, network monitor system, right? And basically the way we've done this is essentially, you basically got an optical path between you and your ISP. You stick a prism in the middle. You run the light two directions. One goes into your border router and one goes into this intrusion detection system. What that means is that each photon is reaching the point at the exact same time. The reason why security people put things in line is because you want to catch the thing happening first, right? But what that does is slow everything down and put a big border up, right? When you send the packets to the same thing and you start analyzing it with a really, really high performance analyzer, at the same time, you're not hampering the data, you're letting it go, but because most of your workflows are large workflows, if something is weird, that thing can shut it down before it causes any damage. So it's really proactive data analysis versus sort of the reactive and, close everything down because I feel safer and I'm going to hold my gun at the door type of thing, right? So that's how that works. And then, when you go even deeper into an alternative security model, right, there's these wonderful things that we've been able to do for about, 40 years called network segments, right, where you can actually create segments of your network, different IP ranges, different VLANs, different things like that, and you can really control at the switch and the router level what can talk to what and what can't, right? And so you can really just, through simple VLAN authorizations and really tight access control lists between them, really hide something so that nothing can get to it, right? And if we move a little bit forward here, multi-factor authentication is a thing that we should be doing, right? It's just plain and simple. So, NIST just released a statement basically saying that passwords are a thing of the past, all right? All the hackers know all the tricks, no password of any complexity, or even if you change it every day, is going to keep you safe, okay? So multi-factor authentication is the only way to fix that, right? Because your password or your authentication key only lasts one time, right? And you're the only one who knows that. So that's a really good way to keep a relatively open environment safe. And you never have to change your password again. So that's an interesting thing, right? The other thing is deep integration of identity and access management, right? We talked a lot about it throughout the panel this time, but if you really treat if you treat security at the point of data that matters, right? Now you can open up your environment a lot. That 1% of data that needs tight security, limit access to that through multi-factor authentication and a security group in Active Directory to a very few bits of people that can access that. And then don't have your system operating that with a root password, right? Amazon does this all the time. You can't use a root password there. There's a good reason. It's certificate-based access only, which means that a hacker really can't get in, right, to get at that data, right? So you've really secured yourself in a lot of interesting ways. A quick new innovation here that came to us from one of our customers is this thing that sort of lets you have your cake and eat it too in these science environments, right? This is something called Direct Flow Assist, which was pioneered by Arista and partnered by Palo Alto and is going to be extended to other firewall things. The bottom line here, since I went over with kicking the HDMI cable, is that this is really close to content-aware filtering, right? Which is really where we need to go. It seems like we could do a match on this type of data needs to do this and has this transfer profile. Are we sure we trust the source? Yes, okay, let it through, don't put it through the firewall. That's exactly what this does, right? And it does it through a security policy on the firewall. And everything else that aren't those trusted policies that we know what to do with, they go through the firewall, right? And the firewall basically is a firewall on a stick, looks like a lollipop hanging off the thing so that either it's in line or it's not. It adds a lot of flexibility to the environment. So what is this? I think I have like 2 slides left. So what does the distributed security model really do? And so this is a distributed security model, in case I didn't say that. Instead of having one thing doing your security, you got a few things doing your security. It's harder to manage, right? But it allows for performance and clean paths with your security. If you keep the data path simple, that's a theme that we've been repeating all day here. Keep it simple. Then it's a lot harder to hack it. When you have a lot of complexity at your border, there's a lot more weak points to go through. The other thing is that using something like Bro allows you to effectively monitor 100 gig connections. There aren't any analysis systems today that really do that well, right? Bro operates in a clustered mode. It's basically an HPC system that in parallel analyzes those data paths. So you can make a cluster of arbitrary size to handle a whole lot of data at once, which is actually going to be able to analyze things in real time at those speeds. Again, treat data, it allows you to treat data with the proper levels of security. You can keep the high-risk data locked down with access control and MFA, but don't run the elephant flows through the security equipment that can't handle it, because that's the use case and that's what needs to happen. So in the end, we all need to stop making excuses, right? This is actually a really exciting time to be in information security, right? The realities of compromise are higher than ever, but we need security, right? This is a very, very real issue. Anyone who's seen control logs at the border of any institution knows that hacking attempts happen, several thousand times per second for most organizations. This is not something that you can ignore. But the thing is, we all have to stop thinking about it like we did 15 years ago, right? Things have evolved. Right? Small things like separating the control plane and the data plane, where all your data is going, of your border networking equipment so that they don't talk to each other. All modern equipment does this, right? If you're lazy and want to SSH to your box from outside, you've opened your control plane to the data plane, and yes, that's a security flaw. If you don't, and you put it out of band and access it through a cell network or something, you don't have to worry about that. So now what you can do is have your internet connection coming into the same thing that your data center is coming into, and you've saved yourself money, you've simplified your network, and you're secure, right? To keep ahead, we have to learn to innovate, right? The hackers are, right? They're innovating every day. They want your stuff, right? So if we're thinking 15 years ago, we're not going to keep up. And you have to be vigilant, not fearful, right? Fear is going to kill innovation. Let's learn something, let's try something, create a sandbox, try this in an environment where damage isn't going to go forward. If we do all this stuff right, science wins. That's it. Thank you. Any questions?
I have a question. What's the single most important thing that an organization could do to improve their security posture right now?
Limit the access depth, right? So I think the simplest thing to do, that's easiest to do, is lock down your border, right? Not with a firewall, but by access control, right? Close down to what you really need. You can let all your inside out, because hopefully you trust that, right? And if you don't, you've got other problems. But for the stuff that needs to come in, open it only to those things, right? And understand your port situation, right? And only open those. That makes it way more defensible. The second thing is enact good identity and access management, because on the back end, that's going to be your last line of defense. That's how I would answer that.
Opening it up, questions on anything for any of the panelists, including from the panel.
I have a question. Yeah. I'd like to ask the audience along the security line, how many of you all feel that you have a very good understanding of the network traffic going in and out of your border? And for how many do they feel it's a black box? So how many feel like you have a really good understanding, you know what's going in and out of there? I see one person in the back.
Yeah.
How many people have any idea what we're talking about?
And how many people? How many people feel like they don't know then? Everyone else, okay.
Yeah. The InfoSec people don't like to share. I think that's the...
Yeah, I mean, the other interesting thing I think is that security people tend to be incentivized incorrectly, right? The incentive is if a hack happens or we get compromised and we lose data, your head rolls. That's the incentive, right? Living in a fear-based society makes it really hard to innovate, right? So what we have to do is say, okay, since incursions are going to happen, right? Because they will happen. Who has been hack-free forever in your organization? Right. So you don't count. It's going to happen. So incentivizing them to make it not happen isn't going to get it there. How about we incentivize more of how many days have we gone without an event, right? When that happens, now we're innovating.
Yeah, that reminds me of the old joke about when you see 0% failure, that just means your monitoring is broken. And back to Adam's point, the question, if we're truly fearless about failure, you should expect to see failure.
Yes.
If you are not seeing sprints get blown up because the team changed what they needed to do in the middle, if you're not noticing the attacks from time to time, it's because you're not looking.
And that's a general cultural issue, right? Is that, don't as management, don't be afraid of failure. That's an opportunity to learn, right? Analyze your people and your workforce based on how they recover from those experiences.
One more millennial thing, postmortems. Super
postmortems
important.
are great.
They love doing postmortems. They're really painful and uncomfortable, but they help.
Mm-hmm. Yeah.
So I guess this question's open to any and all. Really great rumination on sort of experiences and insights from the last few years. But what about forward-looking? 3 to 5 years from now?
It's okay, just talk.
Put it right in front of my face, huh?
We could hear you okay. It was all right.
Yeah, that's what I thought. So just curious, in the next 3 to 5 years, what are the technologies to most likely become disruptive? Right, they may not be there yet, but there are things to keep an eye out for.
I'll let Aaron start.
If I didn't drop enough hints in my talk, I think I did something wrong. I'm actually going to creatively allow others to answer because I have too many opinions here. But I just wanted to inject one thing about security is just be proactive and not reactive. I want to triple underscore what Ari said. That was the question behind my question was if you're reactive, it means you don't check. If you're proactive, it means you get in the junk and see what's going on.
Yep.
But I will let others answer that question.
And I'm going to totally hijack that question because it's the one I wanted to end on, which is to the entire panel, briefly, succinctly, 144 characters. What do you walk out of here thinking about for the future? What's the thing we see at the conference, and what are we talking about and thinking about in this industry for the next year?
You want to start at the end? All right.
Yeah.
So I actually wrote this down during the thing. So I think if I had to name and shame particular technologies, it's serverless and microservices and functions as a service that will be sort of transformative over the next couple of years. Serverless will be the low-hanging fruit. The problem with microservices is you need to actually program and have APIs. And if you have a collection of crew who are shell scripters and sort of glue people, you need real software engineers to do real microservices. So there's an architectural and sort of team building leap there. But for me, function as a service and serverless stuff is the transformative stuff. And in terms of what I would want people to leave the room with, I've been doing this type of work for close to 20 years now, and it's a never-ending exchange of what problem are we fighting today. In the early days, it was compute and HPC. Then it became a couple of years where petascale storage is really scary and risky, and then that got easy. Now the current challenge is network at the perimeter and outside of the boundary. But the thing that, particularly at this particular conference and going to the talks and seeing the trade show is I think my last parting words are breathing room, because it actually feels like in 2017, IT is solving IT challenges slightly faster than those silly scientists are creating them for us. It feels like we really have, hit that curve where the challenges are being addressed a little bit faster than the scientists are creating new ones, and that makes me feel very hopeful about the future. I think that the word is breathing room. It feels like we're slowly getting to a point where we might have some breathing room on the whole IT science divide over the next couple of years.
Awesome. Yeah, that dovetails in perfectly because we need breathing room because we are going through a really transformative time where a lot of paradigms are shifting. Over the last decade, we got very comfortable with a lot of the way server designs were thrown out. We've largely taken PC computers and thrown them in racks and thrown PC operating systems on them and then abstracted and moved forward and forward. But all of that is absolutely not going to work in a multi-cloud microservice environment. So I used to really say, you know, it's just time for the Web 2.0 and HPC to get married and have a scientific platform child. And so really this became real for me attending some enterprise conferences this year and seeing actually in some ways enterprise is ahead of science now because they realize how old and busted they are. So there's kind of a duality there of people that are doing the established enterprise IT and people that are trying to move forward to the kind of concept of the third platform and what's next. And they see that chasm and they're actively trying to build solutions to cross it. I feel like what happened was, you know, scientific computing and research support in IT really kind of forked off of enterprise. And, you know, we kind of did our own thing and made some gains and made things better for ourselves. But I feel we're actually kind of blind to the whole movement and need for the third platform and either don't think it applies to us or just aren't ready for it. I don't think we're seeing that chasm. So I really think over the next couple of years, what I'm hoping will happen is the lights are going to go on and we're going to realize that chasm is there, and we won't make the mistake of just jumping onto what the enterprise has done to catch up, but instead we will still continue to pave a path for a scientific platform globally that fosters science, and that we will actually then take up that challenge and transform. And for any specific, less hand-wavy things, just see my slides.
Oh, actually, before we move on to the next one, I'm supposed to tell you, people have been tweeting at me. All of the slides will be given out at the end. CHI has your email addresses, so we'll give away all the materials as well at the end of this.
I'm going to do this in 8 bits, or 8 words. So since this is all about data, it doesn't matter whether you're talking about networking, storage, or workflows. What I always do, I collect, index, analyze, visualize, find patterns, automate, and repeat. Just do it with everything. It works every single time.
That's going to be shared too, right? That's awesome.
Yeah, so I think, thinking ahead, biology has obviously now become a tech discipline, and I think in 3 to 5 years, the technological change I'm not really that interested in. I think it's about the people, and I think, at BioTeam, our mission statement is enabling science. I'm starting to figure out that enabling science is just enabling people. So my takeaway is to own the mission, and if it's not your mission, you won't overcome the resistance, right? And embrace the grind.
All right, and so my answer to this is follows on Adam's really closely, and that is that I think in the next 3 to 5 years, we're going to see more and more things abstracted away from the actual infrastructure problems, right? It's not going to matter where your disks are. It's not going to matter what your compute is. It's not going to matter which cloud you're using. There's going to be some middleware that makes your life a lot easier and reduces the universe of what you have to pay attention to something that you can really take a look at and really understand. And follow on to that, I think why that has to happen and why it has to happen in a specific pattern is that scientific computing now must reach the long tail of science, right? It's been sort of limited to sort of the high part of the tail for a long time to specific individuals who were innovative and pioneering and to people who had the sophistication to get there. The reality is that lab scientists who have never touched a command line, know what a command line is or think a command line's a bad word, aren't going to be able to use it, and they're not interested in using it. They're interested in using a workflow that's going to get them their answer, doing it through a web browser or from their iPhone, and getting that done, and that's not an easy problem to solve, but that's where we're going to go, I think. Dwan counts.
I think we need to get more of the population in. I completely agree with Ari that managing identity and authentication in a way that we can have citizen scientists and research participants and researchers and technologists all interchangeably contributing without having to have, a dozen passwords and a dozen RSA fobs and all of that. If we can enable the community to work better together, and like you said, the technology for this exists. Like, I have a Fitbit. I can share that data with my family. The technology is there, we just need to adopt it. And if we can get more people in, these problems get easier. That's my thought.